So I'm here on the campus of ETH in Zurich, just outside Zurich, with a professor in the Department of Physics, Sascha Quanz, who is working on a fascinating new initiative, which has only been in the works for, I believe, maybe even 6 months or less. I'm not even sure. I only learned about it at the Europlanet Society Science Congress in Granada. Were you in Granada? I saw the presentation.
Oh, I couldn't make it. No, I had other appointments. Unfortunately, I couldn't make it to Granada this time.
But luckily, Sascha talked to me today in the interview about the mission, life, and it's kind of tell us a bit about life and how it picks up from earlier initiatives that were actually abandoned by both NASA and ESA, and how NASA and ESA might become partners in this initiative.
Yeah, so LIFE stands for Large Interferometer for Exoplanets, and the goal of this mission is really to investigate the atmospheric properties of a large sample of extraterrestrial planets, many of which should be similar in size and mass as our Earth, for instance. And what we did is we looked at what NASA and ESA did 15 to 20 years ago, where they had similar ideas already in their plans, but then these missions got cancelled. And we went back to these first ideas and we folded in new technology, a new scientific understanding of exoplanet science, and we believe that such a mission would really be not only timely but also be able to address questions that no other telescope and no other mission could actually address.
And you actually are going to be looking for biosignatures. Tell us a bit about that.
Indeed. So it's not only understanding the diversity of exoplanet atmospheres, we could also use that mission to look for indications of biological activity in those atmospheres. Because on Earth we know, for instance, that life changes the atmospheric composition of our own planet. And if other planets also host life, similar processes may be taking place, and these imprints, for instance, methane, oxygen, these imprints of biological activity, we could identify with a mission like LIFE.
And you're going to be doing a survey for totally new planets. I mean, around, and you said these stars may be stars that are not that far from us,
Yes.
but we haven't been capable of detecting the planets. And tell us why this mission, it's an interferometry mission, would be able to detect planets that had heretofore been undiscovered.
Indeed. So we are really looking for planets around the nearest stars. We're talking about planets around stars, the stars you can see with the naked eye in the night sky. And so far, the technology that we use and the instrument we used, they are not good enough to find all the planets around the nearest stars. It's not for lack of trying, it's simply a lack of technology advancements. We hope that the current technologies will continue to push further and find more planets, but at this point in time we believe that a mission like LIFE should first have a search phase where we look for the best possible targets around the nearest stars in our solar neighborhood, and then pick those that are the most interesting ones and follow up in greater detail.
And so you would be looking at mid-infrared emissions from these planets. And that's totally different from anything that's been done before. And why is that important?
That's very important because we don't rely, for instance, on any specific orbital inclination from the planets. The LIFE mission is a direct detection mission, so it can take pictures of planetary systems. So we don't have to have the planet orbiting the star so that the planet passes in front of the star and does a transit, like it's the case for the TESS mission or the Kepler mission, and we are completely agnostic to the inclination of the planet, which is great. So we can detect most of the planets that are out there.
And you would be detecting the key biosignatures of life, water, ozone, methane, potentially nitrous oxide, laughing gas, and looking for them and looking for these species of chemicals and quantities or molecules and quantities that would indicate biology. Is that correct?
That's absolutely correct, because most of the molecules you were just mentioning, they have absorption features in the mid-infrared wavelength range, and this is exactly where the LIFE mission is going to look.
Well, good luck with it. I know that you have a meeting next month at JPL as a workshop. You're going to be talking about this mission and other ideas. And thank you so much for your time today.
Thank you so much.